Good morning, all of you. Actually, after long days, so we are here to see the some part of remaining part of the chapter number third. That is the only remaining is part. C programs. Some of that will go with that. Uh, so if you observe that in the chapter number third, we have done with the last time the serial communication. Either I am transmitting or receiving, and how to write the code for then how to check that. Okay. So this last lecture we have seen that. So only remaining with the C programs. So we'll learn about how to write the C language code. Very easy is that we know that we have written the code in the assembly language programming. Okay. So assembly language programming, we have seen that we need to use the here some sort of mnemonics. Okay, so we'll perform simple addition of the 2-bit numbers. So how I am doing that, and we'll see the both the codes in assembly as well as the C. How to convert this assembly to C language. Okay, so starting with the address, we know that 00 we are using. In this case, we don't want that also. Okay, so I'm doing the addition of two 8-bit numbers in the assembly and the C program. Okay. Suppose I want to take the two numbers, so I'll take in the R0, comma hash 0 2 H. Okay. Then move. I'll take in the A register A, comma hash 0 2. So I'm taking these two numbers in the R0 and the A registers. So move indicates that taking the data into the R0 register. That is the immediate addressing mode of that. Okay. Then I'm using the instruction add A, comma R0. Okay. So what happens in that? The addition of the A and R0 will be performed here. Okay. And if you want to continuous, I'm using what? As a jump up. So do it the continuously. So I'm writing here. This will be the continuous. So here is what happened. I already comment. A will get the value of A plus R0. Means the contents of R0 A will be added. Means the 2 plus 3 will be added and the answer will be A in the accumulator save itself. That will be the 5. Okay, a simple addition of the two 8-bit numbers. Now, how to go with the C language? It's very easy. Is there? Let's understand that. Okay, the thing is that as we're writing the mnemonics here, so it is for written for the 8051, the fixed formats. We have the operand 1, operand 2 that will indicate that the source and the destination. And for move, we have the opcode value of that. Meaning is that the opcode values are always storing in the ROM of the controllers. Okay, and when it comes like move R0 comma hash to a specific ROM address, so control understands that the contents data value 02 we have to take in the R0 registers for this move instruction. Okay, and after doing addition, A will get the contents of A and R0 will be added here. Same thing I'm writing the C, as this mnemonics will not be there. I need to use directly R0 is equal to 0x02. So 0x indicates the hex value here. We don't want to write here H here. Okay, same way I need to take the second value 0x03, right, the comma. So two instruction I written like this. So in the C language, I can define the variable R0A and then take directly value into the like this R0 is equal to the. Means I need to remove this part only, and here I have to write the equal symbol. In the same language, you need mnemonics to understand what is action to be taken. In this case, the C language directly indicates that R0 will be value of 02. I'm defining like this directly. Okay. Then what I need here, I want to use the equation that is directly A is equal to A plus R0. Again, comma. And I need to keep in the curly bracket. Okay. So this is opening curly bracket and this is closing. So this will do the perform the addition of the two numbers. But I want to keep in the complete loop. So I'll use the while and the put one indicates the true conditions. So unless when the while keeping the while loop, so depends upon the value defined. If writing x greater than 10, so unless I'm creating x variable and it will not be increasing the step by step, it will keep in the loop. Otherwise, I'm putting here while in comma in bracket 1, it indicates the true value. Means it will go in the infinitesimal the loop. This will execute it. So this is simple code for the edge jump. So edge jump I'm replacing with the while loop here. Okay. Then what I need here, this I'm writing for what? 8051. So we need important header file of that. Hash include insertion operation register 51.h. This register 51.h indicates the header file for the 8051. Then only it will be executed this code in the C program. Okay. And then we have the wide main. That is the main program starts from here. This is the function used to indicate. Either we can use wide main or wide int or int main also sometimes. Okay. And this I am again keeping in the loop. Curly bracket complete to. So this simple code I am converting addition of the two numbers in that. I hope so you understand that. Thing is that we need to add here header file register.51 for every C program for writing for the embedded C, and then wide main to indicate the main program start from here. Now it will not execute. Why? Because I use these variables and that I need to define here. So use here unsigned characters, or you can use integer also, or 0, comma, a, and then semi-comma. So what was the values I used, it will show in, I'm using here. So this simple code is for the addition of the two numbers. It's too easy. It's not that much difficult. We'll execute this also. We have the code. Let's understand. I'll open that code. If you see here, I have written the code for that same way. Rather than I'm using here R7, R6 and accumulator. Okay, same I used here. You can see hash include registered 51.h, then wide main in curly bracket unsigned characters. I define a what if you want that a only in R0, that also will be okay. No issue in that. Rather than taking that values, I'll use here what is where written the code. No issue R0. So I need to define R0 for this, and this will be A. Okay, so A will get the value 3 and 2. And here need to use A and R6 plus R0. Then semi-comma. Just save and build it. It will be build. I'm writing and the hex file also created, and that can be uploaded in that. So A will show the result of that. So just to go with the build option, debug, build already, and just run and stop. We'll get the value of that. We can see here. But it will not show the R0 and R7. So by default, these two registers we used. You can use any register, but in the C program, it will show by default R7 and the A. So A will contains of the 5. You can see 2 plus 3, 5 answer. Okay, I think you understood this. Thing is very easy. I'll show here. So what was the assembly numerics I used that I replaced and directly I written here. So what is comment I'm writing that I have to define. So use directly variables and that variable value is equal to that. Okay, same way we can perform multiplication also. If you see here, I'll do the multiplication of these two numbers. Just replace this symbol by mul instruction. Multiplier instruction. So that will multiply 2 into 3. That will be 6. Okay, so I can use here. I want to insert. Okay, 6 will be there. No issue in that. So just debug out and build it. Syntax error. Okay, semi-comma is missing here. Build it. Now I come to get the value to 23, it will be 6. See, 23, 6. Same thing, what we had done in the mul instruction. So I'm replacing that. Mul operation means what? Multiplication. We need to use, in the C language, we have to use just symbol of that. Okay, so it will multiply these two numbers. Same way, if I define here, I can perform division also. So let's see, we have to write the experiment number on the based on the C. This will be the first program performing C language arithmetic operations, addition, subtraction, multiplication. Okay, so I'll do the multiplication also here. So I'll use here 8 number, and I'll divide A by R0. So we have to use this symbol. Okay, so just build it. Okay, division, I need to use that mod operation, I think. Then we will perform it. No, mod is by 0. It is showing syntax error. Okay, it's showing R0. That's why, sorry. R0. Then, okay. Syntax error near A. Then it might be it's mod operation only. Syntax here near A. By R0. What is the logical operator for division in the C? This is only, I'll check. Just wait. muted. Okay. So as I muted. So this was the code for transmitting the serial data. Okay. Okay. So before that, okay, I'll show that addition division also operation. I was muted. That's why I'm repeating that part also. So first I'll repeat that part and then we'll go with that. I think you're not understood. Okay. So error was what? And comma was missing here. That's what it's showing. So I'm dividing 8 by 2. So that will give me directly 4 answer. And you might see in that previous here. Okay. So I'm looking for. Just wait. Execute run. See 4. So 8 by 2, 4 I'm answer I'm getting here. So this was missing. Actually, I was muted. Then I'll add that C file only that I need to perform serial communication. This is removed. Build. So I'm looking here. See, to get baud rate of 9600, that FD value loaded as in the table, and then SCON, because I'm transmitting and also I'm checking transmitting and I'm checking in the mode 1 operation. So that defines here red bit mode 1. Okay, that's why 50. So 0101 that defines SM0 SM value 1. So mode 1 operation I'm transmitting. So what I'm transmitting, so I started the timer TR1. So that will indicate that my message is going to be sending with the baud rate of 960. So this part will define the baud rate. Now what I'm sending, move a comma hash a value y. So first character y I'm sending, and I'm calling a call send. That indicates that it will go directly to S mode here, that send subroutine. In that I'm sending S move S bomb comma a. So what was y value is there? It goes in the SBUF register, and that SBUF is connected to the other peripheral outside the device. So first character go is there. Okay. How much time checking? Either that TI flag is not set unless this is in the loop. Okay. Once TI flag is set means that a character Y is going to be transmitted out. Then clear it, return back. Return back what? At this moment. Then take the next character. This is process. Same assembly language we are seeing with the mnemonics. Now let's see in the C program what is there in that. Okay. So to use that delay in all these things, I'm creating here subroutine. So that indicates the this is my subroutine for creation of delay, creating one function. The first part is a hash include register 51.h. This indicates it's a C program I'm writing for the 8051. Okay. So what is it now? White delay in bracket unsigned character. So this indicates the delay subroutine. Okay. So I'm creating I value and taking the for loop. How much times it will be in the loop? And unless this value I is coming up to the 10, this is in the loop. Okay. So that means when I'm calling delay operation, it comes here, it will execute it. This is the delay function. Like someone I'm writing a call delay in the assembly language, and it comes to the delay directly delay program. Okay. So what is I'm writing delay? Move that T mod comma, the TH value, TH, TL0 value, that count I'm loading and then starting the timer. Okay. And checking for that flag generation means this is the delay routine. Same way I'm creating a simple delay routine by using the for loop or the while loop also you can create. So I'm writing for in the bracket I equal to 0, I comma, sorry, comma, I less than equal to 10. Means unless and until that I value starting from the 0, it will not issue to the 10 value. It will be incremented, and this is in the loop. Next part, if you see wide main, SCON I'm defining directly with the 50 value, means 0, 1, 0, 1, and all parts are 0, 0. If you observe the SCON contains SM0, SM1, then SM2, and this is for what? Transmission. That creating one is there. Okay. Another parts are going to be that TB8, TB, RB8, and then RNTI. This indicates the 0, 0. Means I'm only transmitting in the S1 mode. Okay, then T mod timer mode to set the baud rate. And loading the value TH is equal to TL equal to FD. If you have seen that, I am taking the value 0 FD in the TH0 in case of assembly language. Okay, but I'm creating here that directly a register is equal to that point. Okay, and I'm writing the TR1 set B TR1 will be replaced by the this function set b. Okay, I'll copy that code here also, so you'll understand easily. This part I'll copy. Okay, let us see now. Okay, before that I'll remove that part, so you will get it easily. The over 0 I have by default. Okay, see. This was the first part to indicate I'm writing the code for 8051 that I had taken here. Now next T mod comma hash 2. So directly I'm taking in the T mod. Okay, T mod is equal to 02. Then scon 50 value. So directly I'm taking scon is equal to 0x50. Means this mnemonics I'm removing and putting equal symbol in that. This indicates the my C program. Okay, I'm putting here equal. And this TRM is equal to 1. This will indicate the start timer, true value. Then to get in SGEM I'm replacing with the while loop here. So while 1 in comma bracket. Okay, so I'm sending that move a comma y. So directly I'm taking SBUF equal to that value character h. So you can take here yes also. Okay, we'll see that part also. What is message I record take? I'm putting here SBUF comma h, that message value character I'm sending. Then delay. How much time? 1 second. So I'm calling that function delay here. A call delay is not defined here. I can call delay also. A call send that way. Then next character SBUF k delay, SBUF b delay. Unless I'm checking that while ti is equal to 0. How? By that flag JNB ti here. This is in the loop. Meaning is that unless the ti flag is not set, it is in the loop here only. So this is replaced by the this function. Once the flag is set, that character HKB is transmitted, and then I need to clear the TI0. So clear TI. Same code, appropriately assembly to the C is written here. If you understand that, let's run that code. I'll show it here in the KL software. Same code is written here. You can see we have other code also, but I'll not go that code. Let's run this. And if you want a space between those two words, I want to keep in the loop. I'll show that first. Is run and go with the serial data. See, okay, it's only coming HKB. Yeah? This B is missing. Okay, I'll go with this code. That is also same way. Okay, same code is written here. White saying I'm creating in that loop only, and I use some pointer here, and that will indicate that go to that particular address. And for that address, I'm writing the this message query COP. Okay, let's check that code also. On the serial monitor, I'll get the message query. Hey, let's see that message query COP query. Means the C code also can be used for writing the assembly language programs. That wide main means our main program what I written same is there. Just I created variable I here. Scon 50 T mod or TH value, then start timer. And the while in the loop, I'm sending the message send means I'm checking for the transmit TI flag and send series COP. And I've created also how much time it should be in displays. For loop I created, and that will be use me delay. Okay, this is the concept of the C programming, and that C programming is for writing what was course as in assembly language. We can write in the C also. Just stop it and go with the next code. Now I'll not show you other codes for the executive. We'll go with the next code is also. See, here also that's very serial transmitted code is written with the baud rate of 9600 means TH value must load with the FD. Okay, that way. It bit data uncontrollably. So as we know that I need to use first register 51 dot h header file. Then I created some character unsigned. Wide serial means what? This is a function I'm creating. I'm calling that function to send the data serially. Okay. Then our main program starts from this. Under this main program, I need to define to get the baud rate of 9600 th value loaded the 0fd. In this case, 0 is not required to load in that. Okay, by default, it will take the value x. Okay, then tmod value 0x2 means I'm using the timer 0 mode to operation. Then scon 40 indicates the mode 0 operation, mode to operation serially. And then I started the timer. And under while, I'm sending the data serial as query. Okay, so same message what I written here, I'm taking that message as pub is equal to that function. Serially, I'm transferring that data. Okay, so first let us query SVERI that serial is sending here, and I'm calling that function wide serial and unsigned on one character. I'm checking that character value is going to be equal to. So x will first will be s, then x equal to v, then x equal to e, x equal to r, like that. So s bar is equal to x value. So that character is transmitted. And how to check that? While ti is equal to 0 means I had transmitted the that's very 5 characters. Once that character transmitted, the flag will be raised, then clear it. Same functions we have seen just now, and now we have performed the on the KL software also. Let's go. This some serial programs are there. I'll show for the stepper motor, and then we'll be finished with the this chapter. Okay. Too many codes are there for that. Don't worry about that. It is too easy. See, this is for generation of the toggling the port pins. P0 get 5 and then P2 get 5 and for wait for some time delay and send the same port with the P0 P1 A value. So that will toggle the port. This is very similar to the move P0 comma hash 55H. That's instruction. Means P1 will get the value 55 and this defines SFR P0 its address is there port 0 address 80 then P1 address 90 on P2 A0 is there. That means I am configuring this port as output port simply. I am defining here. And that I am sending these values and waiting for the some time delay. So that will execute toggle the port P0, P1, P2 for 1 second continuously. I think it is not there for the stepper motor. I think in the chapter 4 it is there. I'll show that also. Okay. When that but just wait, it is too easy. I'll show here only what was the chapter 4 now I'm starting. The chapter 4 code. I'll show it here only for the stepper motor execution, either in the C or assembly language. It's too easy. Code is there. So what is meant by stepper motor? Let's understand that first. The stepper motor indicates the name, it indicates stepper. The step-by-step rotation of the motor will be executed. So it defines, we have the full stepping and the half stepping. If we define full stepping means what was the motor by motor is there. Okay, let's understand this is stepper motor. Okay, so I'm drawing here the symbol of that. It has the 4 wires, VCC ground and the 2 pins are there for that. Okay, so this is VCC, this will be ground, and this is for the data pins. Okay, so D0, D1. So we have to use always one driver IC to connect this IC. So ULN 2003. This simply for the voltage converter I'm using that. Okay, and these pins I'm connecting to the 8051. Interfacing means what? whatever the other peripheral output actuators devices are there, that is connected. So I'm connecting the P 0.0 and P 0.1. This is VCC and ground of the controller. And this pins goes to the that point only. Okay. And this stepper motor has the one rotor here. And on the stator, we have the poles, 4 poles are there. So it operates in the full step and the half step angle. The meaning of full step and half step is what? Full stepping means what? Minimum degree 3.6 degree rotates. In half stepping, it will rotate with the 1.8. Means we know that 360 degree is the rotation for that. Okay, 360, 3.6 to 100. So in the 100 rotation, it will complete the one revolution. That is meaning of the full step. If we talk about half step, it rotates for the 1.8 angle. This indicates what? Angle of rotation of the stepper motor. That we have to configure that. Okay, so simply what? Either I'm configuring this port 0 as a output port, and I'm sending the data on that. What I need to send the data? This is my 8051. It's easy. I'll show it here. Huh? I'm connecting one flag here like this. Okay, it starts rotating with the angle like this, clockwise or either anti-clockwise. We can rotate the stepper motor in the both direction, either clockwise or the anti-clockwise. Okay, based on the value I'm transferring on the poles. So I have here stepper motor internal or external structure like this. So I have the pole. So I can say it's A. And on this, I have the winding of the pole. Internally, I have the rotor like this. This is my rotor. This is stator windings. Huh? Then opposite side only I have the A dash pole, or you can say ABCD also mention that. Okay, on this also I have that windings. So I can say it's A dash, A dash. And here I have the other pole. This is winding. These all are the electromagnets, and the electromagnets have the poles like that. So when the current flowing through that windings, it starts act like a magnet. Okay, this will be B, and this is a B dash. So what I'm getting the values? A, B, A dash, B dash. Okay, so based on this value, our stepper motor will be now rotating. Okay, so I can say here my N pole, south pole. This is N pole, this is south pole. As it is south, it will be N pole. As it is N, it will be south pole. Okay, now let's understand what that. How this stepper motor going to be rotates. Okay, so based on this number of teeth and the poles, the angle of rotation can be calculated for the stepper motor. So I'm using only simple here, 4-pole stepper motor is there. Okay, let's understand that now. So I'm sending the high value on that, and the zero value on that, and the high value on that, and the zero value on that. So what is meaning of this? Means this magnet I have setting the value 1 means this it is active electromagnet. This is active electromagnet. Means what happens? The same poles are coming at the near moment. Okay. So at same poles are coming here. What happens? This is now N pole, and this is N pole. When the same poles are coming here, it repulses. Repulse means what? It starts coming the here. Means this pole rotor will become at the this position, center of the pole. Means it will rotate with the this much angle. Okay, at initial location. So I created what? 1 0 1 0. This is my first code. I indicate the 0A. So I am sending the data 0A at the first. Okay, on these port pins P0, P1, and P2, P3. So when these values are sending for values is 1010, what happens next? Next value क्या करेंगे मुला? This will be 0, this will be 1, this will be 0, this will be 1. Means now N is coming here and this rotor S is coming at this moment. So as this is south pole, this is N pole. As this part is N as act as electromagnet, it will attract the N pole here because this is S and this is N. Okay, means the rotor will come exactly at the position this only horizontally. Okay, so when it comes exactly horizontally, meaning is that the rotation of the 90 degree occurs here. exact 90 degree. Means when sending the 0, 1, 0, 1 will rotate with the it's a 0, 5. Either it can be the 50 or 50. If it is taking 0, 5, it will be clockwise. If taking the 50, anti-clockwise. A0, anti-clockwise. That way. Okay, it comes here A0. Okay, when this pole is coming here, it will be attracting here. Now next time I want to go with the next data. What I need here now? This was 1. This was also 1. Means 0, 1, 0, 1. Now, as this pole is coming with the NS and here also NS. Now, I want to attract this pole. I need to create their 0 here. And here is 1 only. Okay. So this 0, 1. This is also 1. This will attract the S pole on this side. Okay. Means I need to create 1, 0 here, 0 on this poles and the last one. So I need to use 0, 9. So this one means what? And S is coming here. Okay, now this is going to demagnetize. This S will attract the over this terminal. Means sending the values A 1010, 0101, and 1001 like that. I'm rotating the stepper motor in the clockwise. Okay, this is funda used for the rotation of the stepper motor. I think you understood this. So codes for this I'll show it here immediately. I will go with the first stepper motor code and then I'll go with the remaining part. So let's see. This is my stepper motor. I am connecting with so ports I taken different one. P2.0, P2.1, P2.2, P2.3. The 4 pins I used, and I used the driver IC to convert this voltage level. If I understand the current sync capability of the 8051 is in the milliampere, but I need the ratings for this stepper motor different one. The 6 pins are there, so not 4 pins. So 4 pins for the data and the 2 pins for the within the ground. Okay. So when I'm sending the data here 1010 means the stepper motor will start rotating. If you see the code here, same fundamentals I defined. It is the unipolar, bipolar, and that step angle. The angle at which stepper motor rotates, that is called the step angle, and how much angle will be there. Either it is full stepping or half stepping, that will define there. Okay. See, that is called as a wave drive in the full drive mode. So I taken the values that only. Okay, that is windings A, B, C, D, or A dash B, A dash B, sorry, A B, A dash B dash, that way only. Okay, that value is going to be 10001. It is showing the simple 1 pole. But with the full drive mode, it is showing the different values. Okay, and that value I need to send over the port only. See here, it is C code written. I will go with the both full drive and the hub drive mode. I'll copy this code and I'll go with the paint here. This is okay. The same code you can write for the assembly also here. Thing is that it's very easy. What was the delay I created here? So start with the ORZ000. First I'll write the assembly. Then move. Which port I need here? Port 2. So port 2. So I want to make it as output. By default is output port only, not required to send 00 data. Move 00. Then send the value move P2 comma hash 0 through H, a call delay. So that will create the delay. So it will send the data and rotate the stepper motor. In same way move P2 comma hash 0 6 H. Then also a call delay. So I'm converting this into assembly. Yeah? It's easy, or I can go with the reverse way also. Then move P2 comma hash 09H, and 1 2 3 3 6 0 is missing. So first 0, this is not 9, this is 0 0. Then I have the a call delay, then move P2 comma hash 09H, then a call delay. And this I want to keep in the loop, that while indicates one true value. So this I am controlled continuously as jump up. So I'll keep up here. Okay, I'm just writing the delay subroutine. So what is in the delay? This function will define the delay routine. So I need to use here either I can use tmod operation, timer operation, or simply registers also. So I'll use the register r5 comma hash 0ffh and decrement that register value dj and z r5 comma here I can say here only here. Once it will be decrement completely, then return back, and lastly end. Okay, so this is the code for in the assembly language to run the stepper motor with the value sending as I defined in the poles A, B, C, D. Okay, same way I'm taking in the assembly C language also. Hash include register 51.h, then create one delay functions as delay I'm writing here, and then wide main program start from here like over 0 or main program start from here. So what I'm doing while one, so at jump up, so reverse way. What is I'm writing at the end, it will take the first year because I'm to keep in the continuously in the loop that while one indicates. Then P2 comma 03 means value will be 0 0 1 1, that sorry, B and the A dash will be pole magnetized, meaning is that. Okay, so this indicates that two poles will be attract the magnet and the stepper motor rotated by the some delay. Then a call delay, that indicates a call delay, my delay for how much? 1 second. So I can create for 1 second also here, a call delay. Then send the next value P2 0x06. Send P move P2 comma 0x06 hash 06. Then a call delay, my delay, a call delay. Once delay calls, it comes here at decremented of 5 ff to the 0 and comes back here. Then send next value 0 C is there, not 0 0. This is 0 C, sorry. Then a call delay. Then 09 a call delay. So this is the code we have to run the stepper motor in the for specific angle, either in the full stepping, half stepping. This is for the full drive mode. I'm writing the code. Let's see that code and we'll go with the next part. Let's open the new code. So I'll write stepper motor dot C. So I'll write for the C first and then go with the assembly language also. Okay, I have saved this file in there. That was the problem. Control new, paste. Stepper dot C, motor let me save. there is some syntax error that curly bracket is not coming here. Don't worry about that. One, two, 1, 2. That is correct, na? Int I time. There is no semicolon. Okay, this is no don't have problem. What is the problem with the stepper motor? Hash registered T1H wide MS delay or my delay unsigned entire time. Unsigned IJ. Okay, let's see with the assembly. I'm getting the problem with this. It's ORZ 00H. Then move P2 comma hash 00H. It's not required, so I'm using here. Then move. So I need to use copy paste this part. Okay, here I will call a call delay. Then I'll copy that part also. A call delay. And copy this. Four times I need this. So P2 first 03 value, then I have 06, then I have 0C, and then I have 9. If you observe, remember the code that panda. This is not required now. This will be S jump up. So I'm keeping up here. This is up here. Up. A small letter only. Don't make case sensitive. Okay, and then delay subroutine. Delay. Move R5, comma hash. So I'll use here only 0A. Not required to go with that code. S, not S. D, J, and Z R5, comma here. And here will be here only. Then rate and end. End. Done. Just build and debug. Done. So no issue in the assembly program. Let's run, and I need the port 2. I don't want serial monitor now. See, 3, 6, 0, and 9. That value I loaded in that same way. Assembly language code also. So port 2 will be sending the value 3, means that's about to rotate the some angle, then 6, like that. Why it is one time only? So breakpoint is defined, that's why I'll remove the breakpoint and start now. And then the loop. See. So at the pins of the port, last ports, port bit only, I'm sending the value 3, 6, 9, C. That means it starts rotating. The stepper motor rotates the angles only, that way. So that is part of the interfacing of the stepper motor. I mean, you have seen that. And if you see on the logic another also, that waves will be created of that step on, like that steps will be created on that. Let's stop and let us see. This is the C programs of the stepper motor we have seen. This was the last code on that stepper motor interfacing in the chapter number 4. Okay, so we'll go with the initial of the chapter. So chapter 4 of unit 4, interfacing with the microcontroller. It has only 4 interfacing parts, that is LCD, matrix, ADC, DSC, stepper motor, and external memory. So we are done with the stepper motor. So let's understand with the first part of that. I'll go with the matrix interfacing part. Then what is meaning of interfacing all this thing? Let's discuss simple meaning. As we know that in many of the industries, we need to interface various motors or displays and some input sensors also to design the projects. Okay, so in this case, interfacing means what? Connecting the output devices such as the LCD, LED bars, motors, DC motor, stepper motors, along with the microcontroller. Okay, so you have to perform the specific operations in that. So mostly if you observe some way of the malls, when you enter at the gate of the door, that door opens automatically. Means their eye sensors interface, which will sense that someone is coming on that point of movement. Okay. And once it will sense by the particular pin, either I can see any port 0, port 1, that pins will be sensed that someone is coming, that voltage is coming on that pin. Means some live object is coming on that moment. And at that moment, I want to take action. What? I want to run the motor, and that door will be opens automatically, that way. So what was the code just written? That if you write the code there for rotating the stepper motor, and that will rotate the door either in the clockwise or anti-clockwise. I need to run that. Means first I have to open, means it will rotate in the clockwise. So door will be open. After some time delay, I want to rotation reverse way. Same code take it in right from the upper part 0900C1 0603. That will rotate in the reverse way. That is fundamental of the stepper motor. Okay, means that door will be closed. That is part called as the interfacing of the devices, that is LCD motors, keyboards, such that. Uh, so first part in that I'll go with the interfacing of the keyboard along with the 8051. Now what is meaning of that? Let's understand. I'll show it here on the port pin on the LCD. I will go with that. See, I need only four pins to interface as we have the keyboard. Most of the applications we have seen that code also. Oh, this is my 4 by 5 matrix. So we have the values like this. Either I can write it from this or this way. Yeah? 0, 1, 2, 3. Then I have the 4, 5, 6. Otherwise, I can say in the columns also. So this is my first column, this is second column, this is my third column. So I have the four columns, 1, 2, 3, 4. Then we have the same way, four rows are there. Okay, on that four rows, that is 4 by 4 matrix forms, we have the 16 characters. And that character starts from what values? 0. So 0, 1, 2, 3. Then I have the 4, 5, 6, 7. Then 8, 9. 9 is there. After that, I need some values A, B, C, D that I used here. C, D, E, F. Means I can hex value can be transferred. Sometimes we have the 3 by 3 K matrix also that will define the value 0, 9. That way also. Some special characters I need hash, star, that also can be used here. Okay. Now let's understand the meaning how it will be scan the particular number space or not. Okay. So at the any of the port, if you define port 1 here, the four pins I use D0 to D1 means P the 1.0 to P1.3 values I am using here to interface with the 8051. Four pins P1.1, P1.2 like that. Okay, and that connected to the that four rows of the matrix. Okay, these four rows are there. And by default, these four rows are by connected to the ports. It is going to be grounded. Okay, and the columns I am connecting to this VCC part. Okay, so this each column line goes to the VCC, the register 4.7 to limit the current. Okay, now as this value is going to be exactly 00, I need to scan the values which key is pressed. So we have to scan the four rows are there: row 0, row 1, row 2, row 3. And scan value means what? By default, all the values will be 00 on the this 4. Okay, so on the port 0, first 4 bits will be by default 00. Now, and this values will be 111 as it is connected to the VCC. Now, we know one of the key at which column is pressed. Based on that, I can detect the which key is pressed or not. Means by default rows are 00, and then I need to check the column wise. I have to say scan that. Means which column key is pressed. For example, when I press this key, this will be shorting. Means what happens? This pixel directly goes to the 0, and on the port 2, that value will be in sense that means this key is going to be pressed. Okay, means what will happens? This value will be, previously it was 000. This four column row value 00, and the column was 111 once was there. Now as I press this column 0, so I can see 0, C1, C2, and C3 column. This value is 0. When I check that, this becomes 110, means the C0 column is pressed. So I'm taking this data in the accumulator, and I'm just masking with the this value, accumulator value, with the 400 all ones. So I can say that at the which value is pressed or not. Means when you mask that, this becomes value indicates 1 at this moment. Means there is a change in the variable of that. Okay, so I sense that C0 is pressed. Okay, and that sensing and I'm transferring by using the repeater value means the 0 is button is the pressed. Okay, same principle used. Now, second, when I press this key, means what happens? That time, this is for the 0 button. Now, second time, what happens? This will be 1101 means I press the one button. The third time 1011 means I press the third button. Next time 0111 means I press the fourth button. Like this, it will check for the first row. Okay, R0, row 0. Same way, I need to check the masking for the second row. Means same code will be repeated for the second row. So when the particular D1 button, when the particular B is going to be going grounded, means I can say in the row 2, the key is going to be pressed. Same value I have to check for the row 2 also. Then row 3rd and row 4. Means I have to scan this 4 by 4 matrix 16 times. Okay, not 16 times, I can say 4 times. Means for the row 0, row 1, row 2, row 3. The first principle used, same principle I have to repeat for the 4 times. Okay, this was the fundamental used to see check the which key is pressed. Let's understand that code of that. We'll go with what I explained. The same working is defined, and once the key is pressed, it will wait for the 20 millisecond. And once 20 millisecond, that character will be display which key is pressed or not. Okay, let's see that. Huh? So as I'm using that, I'm sensing on the port 2. So I have to define the port 2 as an input port. So if you see and this port, I'm defining the port as an input here, and the port 1 is an output. Data value is going on that. Okay, so that I'm defining code for the move f p2 comma hash ff, means sending high level data on the port that will define the input port. Okay, then port 1 as a 000b, means it is an input port by, sorry, it is the output port by default p1. Then move a comma p2, means just take the status of the column into a. Means what was the data coming on the port 2. If you observe the diagram on here, the port 2, what was the column values are there, I'm taking into the accumulator. That meaning is since the column scanning of that. Okay, then as I'm taking the column data values in A, I am just masking that value in the A. What was the contents on the column value status? I'm masking with the A value. A value, what was that? Column values with the data value 00411. So if it is all the column values are 11, the answer of this will be by default same. And I'm comparing C, J, and E, means compare jump not equal to contents of A with this value in A, which is continuous in the loop. Will say that one of the keys pressed or not, it will be checked continuously. This is in the loop. Okay, once column value will be go to the 0, means by default this column will be like this only. Once one of the keys pressed, by comparing with the NLA, indicates that one key is pressed. It comes out of the loop, and the next code will be executed. Then what is the next? A call delay. Same way, move a comma p2. What was the content of the p2? I'm taking the A to sense which key is pressed. Okay. Then NLA, same value, 0 row, the 4-bit indicates the 4 row values on that. And the next 4 indicates the column values. So that's why I'm asking with the higher enable always. Okay, because column status values 111 are there and row values 000. By default is grounded. That's why. Okay. Then I can compare C, J, and E, means what? Compare jump not equal to that value. Means accumulator contains and this value will not be equal, it will in the loop. Okay. If it is not equal, it come out of that loop. Then compress, means certain key is pressed when this contents on the A will be changed. Means when it comes here, A value will be, when I press the key, that column value will changes. For default, I'm pressing the 0 key. Means 0 key means what? This is 110. That time it will come out of the loop and will go for the particular subroutine. Press me again a call delay. Okay, move a comma p2. Then ANL A 001B CGNE like that. Again R press. The different characters are used here, subroutines are used. Again, I'm checking for the second row also. What was the key is pressed or not? Huh? Go with the next flag. See here. So that defines for the same code I am writing for 4 times. Move P1 comma. For this was for the port 2. I'm checking for the port 1. Move P1 comma. All ones 0 means I have pressed the in the row 0, first button 0 button. That is meaning of that. Then take the content of A from the P2, that will be 0 0 1 1 1. Now when I'm comparing this value with the masking of higher nibbles, I'm checking the either keys press or not by comparing this value in the row 0. So means as I discuss here, either I can check for this value, this value, this value as written here. Means when 0 button is pressed, this value will be 1 1 0, and comparing with the masking with the higher nibbles of that. Means when there is a different the bit of the last bit, means 0 base button is pressed. For second case, when 1 1 0 1 coming, first button is pressed. One character will be displayed on the here. It will send to the accumulator. Next, second button press means it's a 1 0 1 1, and last button press 3 number means 0 1 1. This repeating for the 4 rows. Row 0 is over, then row 2, row 3, row 4, like that. The same code is written here. Okay, this is for checking for the row 0. This code for the row 1. Same data I'm taking at this moment. What? One button is pressed. Means all ones, then 1 1 0 1. That will indicate that one button is pressed or not. Take the data into accumulator and compare it, the value with the higher level masking. Okay, and if it is pressed, go over the row 1. And row 1 is defined. Next, in that time I'm taking the data pointer value 1 and I'm transferring. If you see here, 0 button is pressed, that 0 button 0 1 2 3, I'm taking the value here in the data pointer. If you see R0, move dptr comma hash number. So I'm sending the number from that key button, the number 0 will display. So if you see the number 0, I have the data pointer value 0 1 2 3 for the first row. So 4 buttons means 0 1 2 3 I'm pressing, and that will display on that going to the port 1 of the accumulator. Same way I'm scanning for the row 2 at the third column of the row 2. Then fourth column, row 3. Means which button is pressed or not. I'm checking for the column and the row wise. Meaning is that first initially row wise, then column wise. Okay. And whenever in that scanning, if the particular button is pressed, if the row 0, 0 1 2 3 button, in the row 1 4 5 6 7 button, and the row 3 that ABCD what was there, and the row 3 what the numbers what was there taken in that. And whenever that subroutine comes, we have the value sending for that. Row 0, move dptr number hash number. So hash number I'm defining here, the db 0 1 2 3 hm find. Okay, so when it comes to hm find, it comes at the find button, and find is written here. So check just RRCA, rotate the content. What was the content was there? Rotate with the carry in the right. What was the content in the accumulator? And just check for the carry generated or not. If the carry generated, match clear A. And then take that data value and send it to port 0. Means that key press as sense I am sending on the accumulator, and from that accumulator it goes to the port 0. It is for the first row. Same way, when I am going with the row 1, it will check for the number 1 in that 4 5 6 1 6 7. For the row 3, it will be 8 9 AB, and for row 3 CDEF. So this 4 by 4 means 16 characters I am transmitting by checking the first 4 times row checking, and then 4 times column wise scanning. And logic is that all by default all the rows are 0 0 location grounded, and column side the VCC. Whenever I am pressing certain button at this pixel level, means row 1 and the column 1, this goes to the grounded low level value. That I have to sense that. Means this row scanning 4 times and the column 4 times. And that will use transfer of the what was the key I pressed. It will sense and it will display on the particular port which is connected. Okay, so out of this 4, 2 have finished stepper motor and keyboard interfacing we have done with that. Remaining that is LCD and the ADC DAC. We'll see in the next lecture. Thank you.